สวัสดีค่ะ ขอต้อนรับทุกท่านนะคะกลับเข้าสู่งานสัมมนาออนไลน์ BIDC 2023 ค่ะ โดยพลอยนะคะรับหน้าที่เป็นพิธีกรดำเนินรายการครั้งนี้อีกเช่นเคยค่ะ จบกันไปแล้วนะคะสำหรับงานสัมมนาออนไลน์ในช่วงเช้านะคะ ในช่วงนี้พลอยก็จะขอแนะนำ agenda สำหรับช่วงบ่ายอีก2 section นะคะ ค่ะสำหรับงานสัมมนาหัวข้อที่2นะคะ Azure Open AI Services for Gaming นะคะบรรยายโดยคุณบิยองซูคิมค่ะท่านเป็น Senior Gaming Solution Architect จาก Microsoft นะคะสำหรับเซสชันสัมมนาที่3นะคะจะเป็นหัวข้อ ChatGPT AI and the Future of Work ค่ะบรรยายโดยนายแพทย์พานุทัศน์เตชะเสนนะคะหรือว่าคุณหมอจิมมี่ค่ะท่านเป็น Co-founder of Thai GPT นะคะแล้วก็เป็น AI Solution Provider in Thailand ค่ะสำหรับช่องทางการรับชมนะคะสามารถรับชมได้ผ่านทาง3ช่องทางนะคะก็คือทาง Zoom แล้วก็ Facebook Live นะคะทาง Facebook Live ของ BIDC 2023 แล้วก็ของสภาดิจิทัลนะคะ DCT Facebook Live ค่ะค่ะแล้วสำหรับระหว่างการบรรยายนะคะท่านใดที่มีข้อสงสัยหรือมีคำถามที่จะถามทางวิทยากรนะคะก็สามารถพิมพ์ค่ะถ้าทาง Zoom ก็สามารถทิ้งแชทไว้ได้เลยนะคะแต่ถ้าผ่านทาง Facebook Live ก็สามารถพิมพ์คำถามไว้ใต้คอมเมนต์ได้เลยค่ะค่ะตอนนี้ท่านวิทยากรเข้ามาหรือยังคะค่ะและในลำดับถัดไปนะคะพลอยขอเชิญคุณกุมภลิตพุทธิพินโยนะคะหรือว่าคุณกุ้งจะเป็นผู้ดำเนินรายการต่อจากพลอยในครั้งนี้ค่ะขอเชิญค่ะ
ครับสวัสดีครับ Thank you คุณพลอย and good afternoon everyone. Welcome to the BIDC 2023 webinar. My name is Kumpalit Putipinyo and I will be your host and moderator. In this session, we will discuss the topic Azure OpenAI Services for Gaming by Mr. Byung-Soo Kim, Senior Gaming Solution Architect at Microsoft. This session will be approximately 1 hour and 30 minutes in length. Start with Mr. Kim presentation, and then there will be a Q&A section at the end for about half an hour. If you have any question during the presentation, feel free to send them through the chat. Our moderator team will gather them, and Mr. Kim will answer them in the Q&A section. And that will be it for me. So, Mr. Kim, please take the stage.
Hello, everybody. Nice to meet you. My name is Byung-Soo Kim, and I'm working as a gaming solutions architect for Microsoft and have supported gaming customers' cloud journey with Microsoft Azure services for their game backend. There's a lot of excitement around generative AI these days, and I want to introduce Azure OpenAI service as a generative AI solution for gaming. I will share my screen first. So 1.5 hours, I will introduce Azure OpenAI service and other solutions and its use case in gaming area and more depth of best practice examples about the prompt engineering and how we can run OpenAI GPT services with your own data. Azure AI is a collection of artificial intelligence services offered by Microsoft as part of its Azure cloud platform. The Azure AI services are designed to make it easy for developers and organizations to add AI capabilities to their applications without the need for extensive expertise in AI. Azure AI includes a wide range of services such as Azure Cognitive Services, Azure Machine Learning, Azure Applied AI Services, including cognitive search, and OpenAI services. These services are integrated with the Azure platform, which provides capabilities such as scalability, security, and compliance, as well as many other tools and services that can be used to build and deploy AI-enabled applications. The Azure OpenAI services are designed to make it easy for developers and organizations to add AI capabilities to their applications without the need for extensive expertise in AI. And Microsoft Azure OpenAI services allow developers to quickly build, deploy, and scale AI-enabled applications and take advantage of scalability, security, and compliance capabilities of Azure. Not only Azure, Microsoft also has adopted Azure AI across a wide range of its products and services in order to improve the functionality, performance, and user experience. Some examples of where Microsoft has adopted Azure AI at scale include Office 365 and Dynamics 365, Bing and LinkedIn, Xbox, and gaming. These are just a few examples of how Microsoft has adopted Azure AI at scale within its products and services. Overall, Microsoft has been using Azure AI across its various products and services to improve user experience and to offer more personalized, efficient, and automated experience to its customers. I hope to introduce the brief history of artificial intelligence. Artificial intelligence, AI, has a long and storied history that spans many decades. Some of the earliest work in AI was done in the 1950s and 1960s, when researchers first began to explore the possibility of creating machines that could think like humans. During the 1950s and 1960s, AI research focused primarily on symbolic AI, which involved creating symbolic representation of knowledge and using them to solve problems. Researchers in this field developed the early version of what are now known as expert systems, which are computer programs that mimic the decision-making abilities of human experts in a specific domain. In the 1970s and 1980s, AI research began to shift away from symbolic AI and towards sub-symbolic AI, which involves using statistical methods and mathematical models to solve problems. This shift was driven in part by the realization that symbolic AI was too complex and difficult to scale, and in part by the development of new computer hardware that made it possible to process large amounts of data quickly. In the 1990s and 2000s, AI research continued to evolve and new subfields began to emerge. One of these was machine learning, which focuses on creating algorithms that allow computers to learn from data without being explicitly programmed. Another was neural networks, which are mathematical models inspired by the structure and function of the human brain. Recently, generative models like GPT-3 and DALL-E, variational autoencoders, generative adversarial network, and many more have risen and continue to advance the field of AI. These models are able to generate the new examples that are similar to examples from a given dataset. It is being used in diverse fields such as natural language processing, computer vision, speech recognition, and many more. Overall, AI has come a long way since its inception in 1950s, and it continues to evolve and improve at a rapid pace today. The future of AI is models that are flexible, reusable, and that can be applied to just about any domain or industry task. Foundation models are at the heart of many of the latest breakthroughs. These models have been influential in the development of artificial intelligence systems and have played a major role in changing how AI systems are constructed since their introduction in 2018. A foundation model is a machine learning model that is trained on a large amount of unlabeled data, allowing it to be adapted to a wide variety of tasks. These models capture general patterns and structure of data and aim to replace task-specific models by unifying different tasks and modalities into one, eliminating the need to train individual models and integrate several models together. An example is a large language foundation model that can perform various natural language processing, which is NLP, tasks and can be used out of the box due to its extensive training. Foundation models use self-supervision learning and transfer learning to apply information learned in one situation to another situation or task. Training these models can be complex and resource intensive as they are typically large and require a significant amount of data. The scale of these models also plays a big role in the training process. I will demonstrate some large language foundation models sizes evolving. At the 2018 BERT released in 2018, which is a widely used language model, that marked the arrival of the first NLP transformer model. It is an auto-encoding model focused on the encoding part of the transformer, and it has around 340 million parameters. Parameters are used to calculate the size of these models and can be thought of as a connection between neurons in the brain. In 2020, Microsoft announced the Turing Energy model, which was the largest model ever published at the time, with 17 billion parameters. This prompted the launch of Microsoft AI at scale, a division dedicated to expanding the boundaries of language understanding and building the best-in-class models for use by Microsoft and through Azure. This initiative, known as Project Turing, is a deep learning initiative that uses parallel computational and distributed learning and has helped to create a new class of large centralized AI models, such as Turing Energy, TURL-V5, and Megatron through advanced hardware, infrastructure, and technologies such as DeepSpeed and Zero. GPT-3 has approximately 175 billion parameters, even bigger the Turing Energy model. GPT-3 shows the shows that language model performance scales as a model size, data set size, and the amount of computation increase. GPT-3 studies show that the model is a general solution for many downstream NLP tasks without custom tuning or fine tuning. In addition, GPT-3 demonstrates that a language model trained on enough data can solve NLP tasks that it has never encountered. This raises the question of which undiscovered abilities remain in large language models or other AI systems. According to a recent study, since the release of GPT-3, we have discovered 137 emergent new abilities. While individual cases might be dismissed as curiosities, an accumulation of phase transitions suggests a possible qualitative leap beyond a certain level of scaling. For example, chain of thought prompting, which was just recently discovered, works only when a certain number of parameters is reached. I will explain chain of thought prompt more in detail in later this session. In late 2021, together with NVIDIA, Microsoft announced the Megatron Turing natural language generation model, the largest and most powerful monolithic transformer model trained to date with 530 billion parameters, even bigger than GPT-3. It offers unmatched accuracy across a broad set of natural language tasks. Training a model of this size is challenging for two main reasons. It is no longer possible to fit the parameters of these models in the memory of even the largest GPU. The large number of compute operations required can result in unrealistically long training times. This means it's quite challenging to train all these huge large language models, and no longer the fine tuning and custom tuning of the deep learning model is practical for the large language models. I will explain in details about that approaches later in this session. So Azure OpenAI Service. Azure OpenAI Service enables developers and organizations to access and use the most advanced AI models in the world, including GPT-3.5, Codex, and DALL-E 2. These large-scale generative AI models with deep understanding of language and code can be used for a variety of use cases, including writing assistance, code generation, reasoning over data for inferencing and comprehension. The AI solutions in the videos we showed earlier the AI solutions in the videos, which I will show later in this talk, are all built using Azure AI and these same AI models. Microsoft has formed a exclusive partnership with OpenAI to collaborate on the development of artificial intelligence technologies. The partnership aims to accelerate the development of advanced AI systems and bring the benefits of AI to more people. GPT-3 and 4 is for text completion. A set of models that can understand and generate natural languages. Codex is a set of models that can understand and generate code, including translating natural languages to code. It is a descendant of GPT-3 that's been trained on both natural languages and code. DALL-E is a set of models that can generate or manipulate images from natural language. These three models is a representative model services provided by Azure OpenAI service, and you can use those models via API in your own isolated network in Azure Cloud Service. Azure OpenAI Service is deployed in your Azure subscription, secured by you, and tied to your dataset and applications. These large pre-trained AI models, you can use this model to unlock new scenarios. And AI models are custom tunable with your data and hyperparameters, like GPT-3 and the smaller models. So you can fine-tune your Azure OpenAI model, smaller models with your own data, and customize it to your domain. Azure OpenAI service has a built-in responsible AI to detect and mitigate harmful use. And with Azure Cloud Service, you can get benefit enterprise-grade security with role-based access control and private networks. There are tons of use cases with the GPT-3, ChatGPT, and GPT-4. I will not list one by one of these use cases, and I will show the game-specific use cases in later slides. These new generative AI models will transform game content creation. We believe AI will accelerate a fundamental shift in game creation. Our gaming AI Horizon 3 vision is the intersection of creator and player journeys, where developing a game and play a game forms a tight loop. Players can co-create with developers assisted by AI. And developers are able to iterate their ideas faster, testing faster. In AI game creation, where players and creators become equal participants in democratized game creation. So we categorize AI can help accelerate game creation at a build time, and it can expand player experience more dynamically and interactively at the runtime. There might be tons of factors which makes games successful. Among those factors, productivity of game creation and player retention and player acquisition are important factors which make games successful commercially. Generative AI can accelerate these three factors. For example, GitHub Copilot can accelerate code productivity, And large language model and diffusion models can automate game asset generation, which improve productivity significantly. AI-driven customer support experience, personalized promotions backed by large language model can improve player retention with lower cost. How about the player acquisition? New game experience with more interactive NPC behavior and dialogues backed by LLM, more volume of quality contents generated by generative large language model can attract players more. There are the game-specific AI, generative AI use cases in games. As I mentioned, game asset generation and customization can be accelerated with LLMs and diffusion models. And we can build the smart and personalized NPC agent backed by large language model with specific persona. You can accelerate volumes of the narratives by the large language model with consistent scenario and the world views. And you can even generate your maps and levels with your own scripting by code generation of the large language model. You can even generate the targeted contents backed by large language model. And of course, GitHub Copilot, like a GitHub Copilot and Codex, can significantly accelerate your productivity in code generation or when you build your game client and servers. Smart customer support agent can lower your costs to make a customer support experience better. And large language model can custom tune translation based upon the content specific terms and the game specific terminologies. I hope to introduce interesting papers and experiments which demonstrate the potential of a large language model in gaming industry. These researches and papers are from various researchers like Crafton, Bandai Namco, and Microsoft, NVIDIA, and so on. The first one is a research about the generative agent, interactive simulacra of human behavior. In this paper, researchers introduced generative agent, computational software agent that simulate believable human behavior. Generative agent wake up, cook breakfast, and head to work. Artists paint, while authors write. They form opinions, notice each other, and initiate conversations. They remember and reflect on days past as they plan the next day. To enable generative agents, they describe an architecture that extends a large language model to store a complete record of the agent's experience using natural languages, synthesize those memories over time into higher level reflections, and retrieve them dynamically to plan behavior. Researchers instantiated generative agents to populate an interactive sandbox environment inspired by The Sims, where end user can interact with a small town of 25 agents using natural languages. I put the link which has a live demo, recorded demo for this paper. You can visit and see the details of this interesting paper and researches when my session is ended. The second one is the experiment to implement prototype dating simulation game using ChatGPT from Bandai Namco Labs. This prototype implemented based on the concept of Stanford University's generative agent paper, which I introduced right before, and adjusted some setting and gave persona to the agent to match the theme of the dating simulation game. They implemented this prototype used LangChain generative agent class, which I introduced later. In this experiment, the NPC agent backed by ChatGPT works like the following in a high level. Step 1, in response to actions taken by the paper player, the NPC agent reacts appropriately, utterances and actions based on the configured persona and relationship with the player. Step 2, it naturally verbalize and summarize the event that happened between the player and NPC agent and store them in the NPC's memory. Step 3, the relationship between the player and NPC agent fluctuates based on the time the player's action occurred, the nature of their actions, and their impact on the NPC agent. This NPC AI agent that looks from the step 1 to step 3 above can be applied to game of various genres, not only dating simulation game, and has a potential to be an autonomous NPC AI agent, behave like a human with their own persona. The third one is the prototype from Microsoft, how OpenAI codecs can be used to build autonomous NPC agents in Minecraft. This prototype is a demo demonstrating how to use GPT-3 codecs to power non-player character in Minecraft. Through the discipline of prompt engineering, this prototype showed the model how to use the Minecraft simulated player API to write code to navigate the world, mine, craft, and even carry on conversation. This demo and code was published fully in GitHub, and you can run it by yourself. The next one is research to build a Voyager autonomous Minecraft agent. Voyager, the first LLM-powered embodied lifelong learning agent in Minecraft, continuously explore the world, acquire diverse skills, and make novel discoveries without human intervention. Voyager consists of 3 key components: an automatic curriculum that maximizes exploration, and second, an ever-growing skill library of executable code for storing and retrieving complex behavior, and third, a new iterative prompting mechanism that incorporates environment feedback, execution errors, and self-verification for program improvement. Voyager interacts with GPT-4 via black box queries, which bypasses the need for model parameter fine-tuning. The skills developed by Voyager are temporarily extended, interpretable, and compositional, which compounds the agent's ability rapidly and elevates catastrophic forgetting. Empirically, Voyager shows strong in-context lifelong learning capabilities and exhibits exceptional proficiency in playing Minecraft. Before this research, this type of the autonomous agent usually implemented by reinforcement learning, but it requires training, and if you change some rules or change games, you need to retrain from the ground. This research demonstrates how large language model-based approach can avoid that type of the repetitive training and fine-tuning. The last one is Sherlock, autonomous horse story agent. Crafton shared their experiment with GPT-4-powered autonomous agent Sherlock, an innovative approach that leverages the capabilities of large language models to successfully navigate the intricate interactive video game Horse Story. Horse Story is an interactive video game based on a non-linear narrative structure. The mystery game revolves around a series of police interview footage featuring a woman, Hannah, talking about her missing husband, Simon. Players must sift through the database of video clips using exact keyword searches to unlock the mystery. Requiring strong logical deduction skills and long-term planning for each subsequent action, Horse Story poses unique challenges for an AI. The game's ambiguous final goal contributes to its complexity. In my understanding, this represents the first attempt to utilize such a complex mystery game as a testing ground for game-playing AI. Notably, Crafton's techniques diverge from the typical use of reinforcement learning, which often requires significant resources and intricate reward design to function optimally. Instead, Crafton employed GPT-4, applying it beginning to end without any additional training. The distinct advantage of this no reinforcement learning, no gradient approach lies in its simplicity and efficiency, particularly for the game Horse Story, where designing and managing reward is a challenging task due to its ambiguous objective. This work thus provides an insightful study of how large language models can be utilized effectively to solve complex tasks without relying on training and simply employing modularized large language model components, opening new avenue for smarter game AI. As you saw in the previous researches and prototypes, large language model is not just for chatbot in games. It can do much general text, and there is evolving ecosystem of solutions and tools to expand large language models' capabilities even further. This ecosystem keeps evolving and greatly helpful to build a large language model-based application more efficiently. I cannot introduce all of them, but want to pick some of them, how those toolchain can be used. This is a high-level example architecture of application which we can expand generative AI capabilities in Azure. You can implement logic to retrieve natural language via Logic App, Azure Functions, and Azure OpenAI services. You can utilize Cosmos DB and Redis for memory implementation for agent backed by large language model. And you can utilize third-party APIs via ChatGPT plugins and your own APIs. You can use OpenAI embeddings and vector database to bring your own data into large language model. I will explain more about the embeddings and vector database in later this session. OpenAI announced the ChatGPT plugin, a way to have ChatGPT execute actions in the web. This doesn't just mean it can go to the internet and browse through up-to-date content and news, but also execute actions for us, like buying groceries, booking flights, and so much more. The implementation is, at least conceptually, very simple. The plugin provides a specification for an API using the OpenAI standard. This is a standard that's been around for a while and is what powers tools like a Swagger for API documentation. Then this specification is compiled into a prompt, which explains to ChatGPT how it may use the API to enhance its answers. Think of a detailed prompt, including a description of each endpoint that's available. Finally, the user asks new questions. If ChatGPT decides it should grab information from the API, it will make the request and add to the context before attempting to respond. This process is already documented in the official OpenAI documentation, though it has restricted access at this moment. Microsoft also announced that it will adopt the same open plugin standard that OpenAI introduced for ChatGPT, enabling interoperability across ChatGPT and breadth of Microsoft Copilot offerings. Developers can now use the one platform to build plugins that work across both consumer and business surfaces, including ChatGPT, Bing, Dynamics 365 Copilot, and Microsoft 365 Copilot. If users want to develop and use their own plugins with their AI app built on Azure OpenAI service, it will by default be interoperable with this same plugin standard. This means developers can build experiences that enables people to interact with their apps using the most natural user interface, which is the human language. AutoGPT is an experimental open source application showcasing the capability of the GPT-4 language model. This program driven by GPT-4 chains together LLM thoughts to autonomously achieve whatever goal you set. As one of the first examples of the GPT-4 running fully autonomously, AutoGPT pushes the boundaries of what is possible with AI. Let's see the demo video for how AutoGPT works.
Welcome to this brief demonstration of AutoGPT. Today we'll be showcasing the AI's learning ability by asking it to research information about itself. Let's begin. The program's first step is to use Google to find relevant websites to what it's researching. Now that the AI has found the GitHub repository for AutoGPT, it's opened it for analysis. After scanning the website's contents, it has summarized them and will now place them in the autogpt.txt file we have opened. As we can see, AutoGPT can teach itself about different topics using the internet, allowing it to have a better understanding of the current world than ChatGPT.
The next one is the Jarvis. Microsoft shared the Jarvis language service serves as an interface for large language model to connect numerous AI models for solving complicated AI tasks. Microsoft introduces a collaborative system that consists of a large language model as the controller and numerous expert models as a collaborative executors from Hugging Face up. The workflow of this system consists of 4 stages: task planning, and model selection, task execution, and response generation. By these 4 steps, Jarvis can utilize, mix and match numerous expert models from Hugging Face, like image recognition, video description, text to search, text to speech, speech to text, and so on. ChatGPT is working as a controller, which model is suitable for the request. It analyzes the request of users to understand their intention and disassemble them into possible solvable tasks, and choose models to solve the planned task, and select expert models hosted on Hugging Face based on their descriptions. It invokes and executes each selected model and returns the result to ChatGPT. Finally, ChatGPT to integrate the prediction of all models and generate the responses. LangChain is a framework for developing application powered by language model, and you can utilize it's quite popular with nowadays the big trend of the large language model, and there are 2 main value propositions the LangChain framework provides. LangChain provides modular abstraction for the components necessary to work with large language model, and also has a collection of implementation for these abstractions. The components are designed to be easy to use, regardless of whether you are using the rest of LangChain framework or not. And use case specific chains. Chains can be thought of as assembling these components in particular ways in order to best accomplish a particular use case. These are intended to be a higher level interface through which people can easily get started with the specific use case. Semantic kernel is a Microsoft solution, is a lightweight SDK enabling integration of AI large language model with conventional programming languages. The semantic kernel extensive programming model combines natural language semantic functions, transitional code and native function, and embeddings-based memory, unlocking new potential and adding value to applications with AI. Semantic kernel support prompt templating, function chaining, vectorized memory, and intelligent planning capabilities out of the box. And prompt flow. Prompt flow streamlines the development, evaluation, and continuous integration and development CI/CD of prompt engineering project. Prompt flow is will be provided as a service with Azure Machine Learning Platform and Solutions. It's currently a private preview. I gathered all those links of the introduced framework tool chains here. You can visit these links after my session and try to use that. The next topic is the prompt engineering versus fine-tuning. Prompt engineering is a concept in natural language processing that involves embedding descriptions of tasks in input to prompt the model to output the desired result. Prompt typically includes a problem descriptions, instructions on how to solve the problem, and examples of correct problem and solution pairs. Here is an example of crafting a topic classifier using prompt engineering to help an insurance company to sort incoming customer questions. This prompt composes of 3 different parts: instructions, examples, and tasks as marked by different colors. Let's look at them one by one. Instructions contain both high-level and detailed guideline. The high-level guideline is to classify customers' question and restrict the output to be between 1 and 3. Detailed guideline map each topic to a number. Choose 1 for auto insurance, 2 for flood insurance, and 3 for irrelevant questions. On the example, this prompt has 1 example for each topic. In practice, feel free to add as many examples as needed for each topic. Note that the order of the example matters, so please iterate and find the best order. The last part is the task. The incoming customer question will be inserted here, following the same format as previous example model has seen. The last sentence prompts the model to give an answer for the last question. There are 2 types of prompt, zero shot versus few shot. Zero shot is the model only see natural language description of the task as shown in this example. On the left, that the prompt only contains instruction and task. For few shot, the model also sees a few examples of the task as shown in the example on the right, where 3 examples are inserted in the prompt. In general, few shot performs better than zero shot, but few shot consumes more tokens in the prompt, so please experiment and compare which one best to suit your use case. You can easily test your prompt in the Azure OpenAI Studio in web-based portal in the Azure portal. So you can test and experiment as many prompts as possible as you want in this playground. I want to share some of the most common techniques to reduce hallucination using prompt engineering. The first technique is to include instructions specifically asking the model not to make up stuff and stay with facts. The second technique is to restrict the output. This is especially useful for classification. Restrict the model to choose from a confined list instead of having it generate free-form category names. The third technique is to add chain of thought style of instructions, which means just that please solve the problem step by step in the prompt. The first technique is to repeat the most important instruction to help the model following it. The fifth technique here is to position the most important instructions in the left to make use of the latency effect. Note that this list is high level and certainly not complete. In practice, each use case is different, so please experiment and try a variety of techniques and figure out the best approach for each use cases. And what is the fine-tuning? Fine-tuning is a way of utilizing transfer learning. Specifically, fine-tuning is a process that takes a model that has already been trained and tune it using a labeled dataset for a specific task. Fine-tuning results in a new model being generated with updated weights and biases. This contrasts with fusion learning in which model weights and biases are not updated. To fine-tune a model, you will need a set of training examples that each consist of a single input and its associated output. When to use fine-tuning? Some of the most common scenarios are listed here. The first scenario is that when fine-tuned less capable models, like ADA Vivid's query in GPT-3 model performs as well as advanced DaVinci model. But it's more cost-effective and faster. The second scenario is when latency is important for the use case. With fine-tuning, the need to provide few-shot examples are eliminated. So the number of tokens on prompts are saved. This enables lower latency requests and save cost as well. The third point is that fine-tuning needs a lot of high-quality data and ground truth labels, starting from a couple of hundreds for each use cases. So customer has to commit to maintain this high-quality data set over the lifespan of the model. The first scenario is the use case is very domain specific, so the model needs to learn from a lot of new examples to know how to do the task, and hence the number of examples needed to don't fit in prompt due to token limit. Note that this is less likely with 32K token limit model. And last, I want to provide some general recommendation on how to tackle a new use cases. First of all, direct use of foundation model with prompt engineering is preferred. Try out a few different prompts and pick the best one. If the background knowledge base is too extensive to include in the prompt directly, utilizing similarity search to create a dynamic prompt is a handy technique, as it allows for the incorporation of the most relevant information for each user query. I will explain more details about how to make a similarity search and vectorize those intensive knowledge base, background knowledge bases. If we have to use fine-tuning, only include the highest quality data in the fine-tuning dataset. Monitor validation metrics and adjust parameters to avoid overfitting or underfitting. Or you can also compare prompt-engineered advanced model versus fine-tuned less capable models. Then look at the performance metrics, operational latency and cost, and select the best overall approaches. So yeah, this is a high-level overview how to customizing Azure OpenAI in prompt engineering. So the providing meta context in the prompt and getting the more responses. In the model naming convention, Azure OpenAI model names typically correspond to the following standard naming convention: family, capability, input type, and identifier. So text DaVinci 003 means the text family model, and DaVinci capability of the model, kind of the model size, and the identifier is it's just for the ID. This model is a GPT-3 text model, the most powerful DaVinci, and the biggest one, and of the latest version 003. And the tokens. You can think of tokens as pieces of word used for natural language processing. For English text, one token is approximately 4 characters or 0.75 words. As a point of reference, the collected works of Shakespeare are about 900K words or 1.2 million tokens. So this is the example of tokens and possibilities. So this sentence can be tokenized with these colors. And these tokens can be used how model predict next word and sentences with the possibilities. So if the prompt instruction is suggest 3 names for an animal that is a superhero, the completion with temperature war, this is already the strict with the given instructions. It responded already the same response. And completion temperature with 1, which is which generate often different responses. So every time you try to get the completion result from the model, it generates the different type of responses. Yeah, this shows the how model use out of the box to handle the prompting. So I already explained how this the model decoder and natural language processing and natural language unit and generations, and how it can recognize the prompt instructions and completions. So this is the example how the model handles those prompts. This is the example of text classification. So in earlier stage of the natural language processing models, it can only perform this type of the task trained by that purpose only. But nowadays, large language model can do this various type of the task in very general capabilities. For example, the named entity recognition, this instruction shows the example of the zero-shot prompt. And the next one is the custom named entities with the several examples, which I explained as a few shot prompt engineering in previous. And this is a multi-level text classification, the prompt with the several examples. So it classifies the list of movies with the categories they fall into. So you can utilize this text classification for the dynamic categorization of the text-based data, any type of data. And paraphrasing. This is the few-shot example of the paraphrasing. So you can rewrite the phrases with the given instructions and with the examples. So you can see how this the few-shot prompt instruction, the model's completion API responded with this few-shot prompt. And reasonable unstructured data, question and answering. Actually, this is a type of the ChatGPT's own the chatting use cases. So when you just ask the question, the model just answered about the prompt. And keyword expression of the few-shot. So you can provide several examples with keyword examples and prompt and keyword, and the completion can generate another keyword extraction from any phrases upon your the few-shot prompt examples. This is a summarization example, the extractive and abstractive. Extractive is just the part of the just the extract the keyword only, but the extractive is more challenging because it should generate a new text thematically correct using natural language generation techniques. So it's more challenging than just extract the keywords from the paragraph. And this is extractive summarization with the few shot prompting. And from the DaVinci 002 and above, you can prompt like to instruct models insertion, fill the gap instructed in the prompt, like this example. Yeah, this is the insert classification of the fusion. And this is a chatbot with personality fusion. So in this example, we prompted with the persona of the robot and with very nice and empathetic. So when you human asked told I broke up with my girlfriend, the robot responded how expressed his empathy on the human's request. So this is the example of the how to analyze customer feedback. Customer with given the customer review, the prompt instruct analyze customer review and provide feedback and sentiment. So sentiment and yeah, in earlier stage of model, sentiment analysis is the purpose-built model's capability, but large language model can do this type of the tasks too also. So large language model nowadays can analyze this type of the various type of the natural language processing tasks even better than the previous generation of deep learning models with purpose built for the specific purposes of natural language processing. Now, there are lots of the examples. Topic classification for band routing. And this is the summarized conversational transcript. So if you have some the chatting or in the game, you can use this large language model to summarize all the conversational transcript and shows the brief summary instead of looking up all the log of the conversational transcript. And product description and generation. This is the future example. So yeah, the large language model can generate the product description, and you can utilize this as this type of prompt, like a game item description and so on. And product recommendation. So yeah, there is this is a high-level glance of prompt engineering guide. So search for a better prompt that elicits more reliable answers and invest in thousands of examples to fine-tune a custom model. Assume the model is incapable of the task and move on. There is no simple answers. Getting the model to reason and provide the desired response is an art in itself. You can use one-shot and few-shot learning, but in many cases, this won't be enough. My guess is that a lot of the work we are going to do as experts is to master this art and come up with techniques to help our customers use these models to derive the outcome desired before going into expensive fine-tuning solutions. The following is a guide to some of these techniques. The beauty of these models is that we don't have to tinker with code. We can simply use prompt engineering. Natural language to guide the model to reason through a human partnership approach. So as you see the list of the guide, the fine tuning and custom tuning of the custom model to maximize performance should be the last resolution of to handle the now the most recent language models, recent generation of language model. So you need to try the prompt engineering and vectorizing and similar search first. This is an example of the prompt training. So with one-shot and few-shot prompt is just for the single prompt example, but with the token limitations and it requires sometimes the multiple prompts and change the result to next prompt. So it shows the example, the entity extraction and summarizations and sentiment analysis change by the prompt training. And prompt chunking is how to handle the prompt token limits. So there is, if we have a large text beyond token limit, and we need to summarize that, we can split out those larger text into the smaller chunk and summarize it parallelly with the multiple prompts and gradually summarize it into the next part. And this is the fusion reasoning. So you may have heard that these models are not very good at doing math or arithmetic or deriving logic. But like humans, if you were asked to multiply 13 by 17, would the answer pop immediately into your head? For most of us, probably not. Yet that doesn't mean humans are incapable of two-digit multiplication. With a few seconds and some pen and paper, it's not too taxing to work out that 13 multiplied 17 is 221. The model needs to be guided in the same way. This is the example how to prompt the step-by-step reasoning and guide more accurate result from the step-by-step reasoning. This is the chain of thought. So the only difference of this prompt is the let's think the last sentence. The let's think step by step and explain the calculation step by step. Before this instruction, actually the result was not accurate. But with the step-by-step instructions, model tried to solve the task step by step and responded with the right answer. Yeah, this is the chain of thought for reasoning. Another example. So first prompt, you reason the extractions, and the second prompt, you can answer extractions. And it's quite a big prompt, the fuchsia chain of thought examples. I will not explain all this stuff. You can read through this prompt how chain of thought fuchsia was was implemented in this example later this session. This is a selection inference prompting. Sometimes chain of thoughts also leads to wrong result. It especially struggles when the example are short but task is long, and sometimes you as a human do not know how to solve the problem yourself. One interesting trick to have the model decomposes the task into smaller tasks and figure it out on its own. This allows the model to reason along the way and can lead to much better result. The technique is called selection inference prompting. I hope to introduce the concept of embedding, which is a core concept of how we can implement the technique called retrieval augmented generations. A commonly used approach to address various errors from foundation model. In the RAG-based approach, we convert the user question into vector embedding using a large language model, and then do a similarity search for these embeddings in a pre-populated vector database holding the embeddings for the knowledge purpose. A small number of similar documents, typically top 3 documents from similarity search, are added as context along with the user question to the prompt provided to LLM, and then that LLM generates an answer to the user question using information provided as context in the prompt. An embedding is a special format of data representation that can be easily utilized by machine learning model and algorithm. The embedding is an information dense representation of the semantic meaning of the piece of text. Each embedding is a vector of the floating point number, such that the distance between 2 embeddings in the vector space is correlated with semantic similarity between 2 inputs is in the original format. Embeddings make it possible to map content to a semantic space. For example, each sentence turns into the vector of numbers. And different Azure OpenAI services, embedding models are specifically created to be good at particular tasks. In Azure OpenAI service, there is 3 types: similarity embeddings and text search embeddings and code search embeddings. The similarity embeddings are good at capturing semantic similarity between 2 or more pieces of text. Text search embedding help measure long documents relevant to a short query. Core search embeddings are useful for embedding code snippets and embedding natural language search queries. Embedding makes it easier to do machine learning on a large input representing words by capturing the semantic similarity in a vector space. Similarity search with embedding examples. Once you encode your content as embeddings, you can then get an embedding from the user input and use that to find the most semantically similar content. So if you have knowledge bases, you can extract embeddings from your knowledge-based text and store it in the vector database. And if you get user inquiries, first similarity search in the vector database and getting the top 3 similar results from the vector database. Then you can provide that as a context into the prompt to the large language model, and large language model can refer to generate more accurate and relevant responses based on that context, the provided context. We strongly recommend using text embedding ADA002 version 2. This model version provides parity with OpenAI text embedding ADA002. And these embedding models quite these embedding model quite efficient to convert the text to embeddings, and it's much cheaper than the large language models and the GPT transformers. So in cost-wise, the make embeddings of your knowledge-based text or your game game background data text or any type of text into embeddings, you can do that with the much cheaper cost than the large language model processes. This is the embedding example. So Q&A with semantic answering with Azure API services. This shows the architecture, how you can populate the unstructured document stored in the Azure storage in the Azure with the Azure Form Recognizer and the Azure Translator and Azure OpenAI service embeddings, and store it into Azure Azure Cache for the Redis Enterprise, which support the vector database, and how you can retrieve the similar result from the user inquiry. Don't worry if you are not familiar with vector database and embeddings. Microsoft announced Azure OpenAI service on your data service as a public preview. Yeah, it's just the 2 weeks ago. You can just upload your documents in Azure OpenAI and configure to refer those documents. Azure OpenAI service manages the remaining tasks, including convert documents to vectors by embeddings, set up similarity search, and so on. You can try it right now in Azure OpenAI portal. If you want to customize embedding processes with your own procedures, you can still build your own Azure OpenAI service with various options. Microsoft shares various implementation options in open source using cognitive search, MongoDB, Redis vector database, PostgreSQL, and pgvector, and so on. So you can refer these examples. All these examples hosted, opened, and shared in the GitHub, and you can visit those GitHub repositories, and you can try it by yourself. Yeah, please keep in mind that there is a API usage and rate limit at this moment. At this moment, the DaVinci model has a 120 requests per minute limitation per second. No, 120 requests per minute, and 300 requests per minute for all other models. And DaVinci models 40K tokens per minute, and all other models, so smaller models, has 120K tokens per minute. All rate limits and availabilities are subject to change, including for specific models. Increased quotas can be requested, but not guaranteed. The Azure OpenAI service currently available in 4 regions in Azure Cloud Service: East US, South Central US, West Europe, and France Central, and expanding more regions soon. To see the list of available regions, please visit the product available pages by regions. This is the REST API reference. It's quite simple. You can you can control your REST API operations to delete and get file content and import, list, upload any of your data. So Azure OpenAI REST API reference, you can refer that in our official documentation. And Azure OpenAI Studio is the best place to get started to experiment Azure OpenAI services. Get started in the studio, refine your prompt and copy your code, and yeah, do whatever. Yeah, this is the end of my presentation today. Do you have any questions?
All right. Thank you, Mr. Kim, for such a hefty presentation. Tons of information. Then, of course, this presentation will be available after the session, correct?
Yes.
Oh, yes. Okay. So if you guys have any question, feel free to type it in the chat on our Facebook page or in the Zoom chat. Our team, our moderator team, will collect all the questions and Mr. Kim will answer it. For now, there's while we're waiting for some questions is already coming in. It's a shame that this is such a versatile, powerful tool that I'm sure it's gonna disrupt so many like business or technology wise. But at the end of the presentation, there's a available region for the Azure Open AI available right now, but there's no Asian or Thailand include. Can you give us a time frame that it might be possible?
So yeah, actually, we are trying to expand as soon as possible. But
Mhm.
as you understood, there is a problem in the supply chain of the GPUs nowadays. It's
Okay.
really challenging. It's really challenging for us to purchase those GPUs sufficient to handle those demands.
Uh-huh.
So yeah, so I cannot guarantee when will it be available in the Asian, but yeah, not only Thailand, actually Korea, Japan, China,
Mhm.
always all the customers in Asia keep asking when the service will be available in the Asian region.
Uh-huh.
So yeah, please tuned in our the product page. Actually, we are trying our best to deliver those services as soon as possible.
Okay. We hopes we will be hearing the good news soon. So
Yeah.
I would like to ask you like some of your perspective on the grand scheme of things. Like the AI, Open AI has been in a hot debate for some time now. There's many concern, many controversies. Like, it is gonna replace human, like for about jobs or that those kind of things, or it's gonna disrupt so many business. And what's your take on this kind of perspective?
So yeah, actually, yeah. So OpenAI, the current the GPT model is not actually. This is just a tool to generate the human-like text.
Mm-hmm.
With the generate the series of the text with possibilities, with as I explained in my presentation.
Mm-hmm.
So even though it seems like it can reasons and generate some reasonable answers or something like that, but actually its current capability is quite limited. So actually, we can utilize this tool very cleverly to automate and to improve humans' own productivity. So, for example, before the conveyor belt was adopted in the manufacturing car,
Mm-hmm.
all the laborer need to manufacture their own car. One labor just from the ground the make their car from with tire and all the parts of the car. But
Mm-hmm.
with the conveyor belt, they the productivity increased significantly with automation,
Mm-hmm.
and there are the job market also expanded yeah, thousand times and million times bigger than those times, right?
Mm-hmm.
So yeah, the productivity the improvement uh, can create another level of markets and another level of the application and yeah another type of the uh, job market too. So we
Mm.
need to know how we can uh, utilize efficiently these capable AIs more rapidly and more efficiently. I think
Mm.
that is the crucial part.
So like we all need to adjust with the technology that these new things coming up, and we need to learn to live with it and utilize it.
Yeah, right.
Mm-hmm. Improve yourself basically.
Actually,
And
yeah, it can lower your our own the burden to like
mm,
the repetitive the trivial task or something like that.
mm,
So if for example if you get some emails of the uh, thousands of or the 10K emails
mm-hmm,
from your inbox, you can make the GPT bot to the categorize the by priority and summarize with the too lengthy emails and just to show the high priority emails first or something like that. So
mm.
yeah,
Or
this is just for
categorize them.
example.
Mm-hmm,
Yeah.
mm-hmm,
Yeah, so
mm-hmm,
it can lower your burden too, and you can focus on the more creative and more valuable tasks, and with the assistant of this kind of the uh, generative AI and the autonomous agent.
mm. So, as you mentioned before, like we need to focusing on we can leave like the labor task to the AI, right? And we can focus on more creative sides of things. Like, but to create something like could an AI gonna have to take mass amount of information and create something out of it, right? What about the originality of it, or the ability to identify truths or false information, or right or wrong information, or by whom or what standards?
So yeah, that is the reason I spent today's session. I spent so many examples of the prompt engineering and
Uh-huh.
actually all this the prompt engineering stuff and the embeddings, and this is the one of the most important goal of this technique is the how to reduce the hallucinations
Mm-hmm.
of this model. So
Mm-hmm.
actually with the uh, yeah, actually, you can imagine the human who is a great liar, right?
Mm-hmm.
It sounds like a true or something, right? Yeah, actually, large language model is cannot determine which is the true and which is the false. Actually, it generates uh, more relevant and just the possible the descriptions, and just like a yeah, it as long as it sounds make a sense, it sounds make sense. It
Mm-hmm.
generate with the possibilities. So So we need to restrict their responses by prompt engineering. How they and we can configure the large language model more strictly based strictly. It can generate based upon the given the prompt and the data. So there are lots of the researches in the generative AI nowadays, large language model. At this moment, we don't have the fully don't have the options to fully remove all the hallucinations and false positives in the large language model due to its the implementation background. But we can reduce it and we can monitor it. So Azure Responsible AI provides some tools to how to filter inappropriate results and how to process those the result and metrics generated from the generative AI.
Okay. And what about people privacy? Do we need to concern about it yet? Like we need to upload our personal information. They can like listen to what we chat during our gaming session or something like that. Do we need to worry about it?
So yeah, if you make a chat in OpenAI directly, not Azure OpenAI, it will be delivered into the OpenAI. And those data will be stored in OpenAI and can be used for the training and improvement of their model. But with Azure OpenAI, you will have your own instance of the OpenAI models, and you can upload your private data or the in company or in studio data in isolated environment in Azure. So you can actually without those the isolation, enterprise customers cannot adopt the OpenAI services because they don't want to open their the the private intellectual properties, right? So yeah, the one core benefit of the value proposition of the Azure OpenAI is we provide isolated the enterprise level isolated environment for the OpenAI model.
Okay. So pretty secure. So no need to worry about it.
Yeah, but you need to care about your own responsibilities. So if your application gathers some the individual the player end users privacy data and expose it to another, it's a different story. So you need to implement your own safeguard, how to filter that out, that kind of the risks from your applications.
I see. Understood. And understandable. Totally. Okay. Some answer from the chat. What will be the future plan or development of OpenAI for gaming?
So yeah, Microsoft runs the various the industry solutions. So Microsoft has the Azure services, and Microsoft also runs the Xbox in directly in gaming area, and Microsoft also has the tool chains and product lines all about the development like Visual Studio and Office Suite and yeah, even Windows OS, right? Microsoft has the ambition to improve our product significantly with this autonomous agent backed by large language model with the Copilot series. And gaming specific implementation, actually we are partnering with NVIDIA and the other partners to provide their the game domain specific solutions via the Azure market space. For example, NVIDIA nowadays announced their new solution, which is called the ACE framework, which can generate the 3D avatar model, uh, and it can generate the lip sync information from the text and of the avatar, and it can generate the narrative in real time from yeah, the NVIDIA showcased those framework in their uh, public event. We have a partnership with NVIDIA, and uh, we will provide their solutions in Azure Marketplace. And Azure also provide have a the partnership with the Hugging Face. So not only limited, actually there are tons of the AI models and tools in the world, not only for OpenAI services. So we will uh, uh, partner the Hugging Face to easier access to those open source AI models, deep learning models, and even generative AI model in the Azure environment, so that the developers can implement their own specific customized models for their needs. This is the high level approach at this moment. And if Xbox can make a productized AI-based the solution, it will be provided in near future, but I cannot. Yeah, I cannot. At this moment, I cannot open any detailed information for you.
There's a lot in the plan, but you cannot announce anything right now. So we will need to wait for the official statement.
Yep.
Okay. And next question: what's the difference or an edge of Azure comparing to other OpenAI in gaming context?
Oh, pardon. Can you repeat your
Okay.
question?
What's the difference of Azure compared to other OpenAI in the gaming context?
In the gaming context,
Yes.
Azure and so do you mean the comparing Azure OpenAI
Yeah.
versus OpenAI?
Like compare Azure to other OpenAI. What's the difference between Azure and other OpenAI?
So yeah, as I explained, Azure OpenAI is the Azure's own instance of the Azure OpenAI model, which is exclusively provided to the Azure customers.
Okay.
In the yeah. So when you call the OpenAI API inside the Azure the the OpenAI services, it goes to yeah. You will have your own Azure OpenAI instance in Azure environment. So all the API will go through the your isolated private network, and you can safely use and experiment any type of the AI experiments in the Azure OpenAI services. But with the direct OpenAI service, you can it's a in, yeah, it's a publicly open service via internet, and it's a shared service across all the users for the OpenAI services. So that is the biggest differences for the for these two OpenAI services. And in model-wise, actually, there is no capable. Actually, we use the same model. We didn't touch any customizations or optimization over the OpenAI models. So no differences.
Okay. Gotcha. Okay, last question. In terms of the future career, what skills are needed to optimize OpenAI for gaming?
So, what skills? Yeah, so actually, as an end user, actually the ChatGPT and GPT is quite popular, but it seems like a just a simple chatbot, right? But
Uh-huh.
but as a programmer or as a game designer, maybe you need to learn about the Python and the large language model, the framework, which I produced the LangChain, which you can use the LLM models programmatically, and which you can generate prompt dynamically with your code. By doing that, you can make your own autonomous agent backed by LLMs. So not only career, you can utilize your you can utilize your skill set for that to improve your own productivity in any industry. And yeah, I believe those skill set is so actually, yeah, I'm the programmer background. so my answer is quite focused on the programming
Sure.
career paths. But yeah,
Yes.
yeah. So yeah, that is the most trendy the career skill set nowadays in programmer careers.
Yeah, I can see that because as we can see in the presentation today, the OpenAI it's really flexible and could be adapt and adjust to use in many industries.
Yeah,
So
right.
you need to. I think there's a big chunk of things that you need to learn how to optimize this thing to suit your needs for your for the workflow or the industry that you are in. So but the future is really fascinating and really like it's must be like great to behold at what's gonna happen next.
Yeah,
Okay.
definitely.
Yeah, well, I think that would be it for today, Mr. Kim. Thank you so much. It's been an honor to be like educated by you and and uh and you give such a impressive presentation. Thank you for joining us today and hope to see you again soon.
Yeah, thank you everybody. Thank you for your time. Enjoy your BIDC.
Okay. Okay. Going back to คุณพลอย
ค่ะค่ะก็จบกันไปแล้วนะคะสำหรับเซสชันที่2ก็ขอบพระคุณนะคะท่านวิทยากรแล้วก็คุณกู้นะคะที่เป็นโมเดเลเตอร์เป็นผู้ช่วยประสานงานในครั้งนี้นะคะค่ะสำหรับเซสชันต่อไปนะคะเซสชันที่3ซึ่งจะเป็นเซสชันสุดท้ายของการสัมมนาในวันนี้นะคะคือ ChatGPT AI and the Future of Work นะคะโดยนายแพทย์พานุทัศน์เตชะเสนหรือว่าคุณหมอจิมมี่นะคะท่านเป็น co-founder of Thai GPT แล้วก็เป็น AI solution provider in Thailand นะคะแล้วก็พลอยก็จะแนะนำsection ต่อไปในวันพรุ่งนี้เลยนะคะค่ะ section ในวันพรุ่งนี้นะคะประกอบไปด้วย5 section นะคะโดย section แรกเราจะเริ่มกันที่9 โมงนะคะ9 โมงหรือว่า9 นาฬิกานะคะ section แรกคือ Class Point ผู้ช่วยปัญญาประดิษฐ์ของคุณครูเพื่อส่งเสริมการมีปฏิสัมพันธ์นะคะบรรยายโดยดร.ชุติวัฒน์สุวัฒน์พงศ์นะคะท่านเป็นอาจารย์ประจำสำนักเทคโนโลยีการศึกษามหาวิทยาลัยสุโขทัยธรรมาธิราชนะคะแล้วก็เป็น Class Point Certified Trainer ด้วยนะคะ Section ต่อไปนะคะ Section ที่2จะเริ่มเวลา 11 นาฬิกานะคะด้วย Topic Inside Spider-Man Across the Spider-Verse นะคะโดยคุณธนาวัฒน์ขันธรรมและคุณทัชพลเลิศวิโรจน์กุลนะคะต่อไปค่ะเซสชันที่3นะคะเราจะเริ่มกันที่ช่วงบ่ายนะคะเริ่มที่เวลาบ่ายโมงครึ่งนะคะเซ section นี้นะคะ topic คือ future of creative content with real time animation and virtual production นะคะ โดยบรรยายโดยคุณปิยทัศน์ลิมสิทธานะคะ section ที่4นะคะ เริ่มเวลา 16 นาฬิกานะคะ topic case study AI Pro Power นะคะ real time NFT generation game นะคะ บรรยายโดยคุณนินอานันต์บัญชาชัยนะคะ และเซสชันสุดท้ายของในวันพรุ่งนี้นะคะ เริ่มเวลา 19:30 นาทีด้วย topic generative AI for e-learning development นะคะ โดยศาสตราจารย์ดร.จินตวีคล้ายสังค่ะ ค่ะสำหรับเซสชันนี้นะคะก็จบกันไปแล้วเดี๋ยวเราไปต่อกันที่เซสชันสุดท้ายของวันนี้นะคะซึ่งจะเริ่มเวลา 16 นาฬิกาค่ะขอไปได้ค่ะเริ่มเวลา 16 นาฬิกาเดี๋ยวตอนนี้นะคะรบกวนผู้ชมทุกท่านนะคะที่ชมผ่านทาง Facebook Live นะคะแล้วก็ช่องทาง Zoom ทำแบบสำรวจความพึงพอใจกับงานสัมมนาออนไลน์ในครั้งนี้ด้วยนะคะ